with the GIC, Geographic Information System Center. They develop solutions and then apply it to large-scale problems around the region. And I'm sure Dr. Manzoor and his colleagues will talk more about that. So from my point of view, this is a very important and a significant tech talk from our side, involving many disciplines, because we're talking about a set of technologies that are broad-based. So with that, I thank everyone. I thank all the speakers joining us, our partners, as well as the audience who have tuned in today. So with that, back to you. Thank you.
All right, thank you very much for those opening remarks, Dr. Naveed. We're going to go ahead and jump right into our first talk for the day. We're actually going to switch the schedule up a little bit. So we're going to have Professor Kees van Westen take that first spot today in this opening of the disaster management portion of our program today. So Professor Kees van Westen is from ITC, which is at the University of Twente in the Netherlands. And so we've been collaborating with him for quite some time on disaster-related projects. And so I would like to hand the floor over to Professor Kees. Please take your time. I believe you have 15 minutes to lead us. So go ahead. Thank you.
Thank you very much, and thank you also for inviting me for this talk. I would like to share my screen. If you could allow me also with the sound, please, included. Okay. Do you see my screen?
Yes, Kees, go ahead.
Yes, good. So my talk will be about multi-hazard risk assessment for risk mitigation and Build Back Better. My name is Kees van Westen, and I am part of the University of Twente, faculty ITC, and the Center for Disaster Resilience. Let me first show a small video introducing ourselves.
The Center for Disaster Resilience is a newly funded organisation with a powerful remit to significantly decrease disaster risk and to promote global sustainable growth. Humankind's constant striving for progress means we live in a rapidly changing world. We grow in numbers, with the population increase from 2 billion 100 years ago to 8 billion today, and expecting to reach 10 billion by 2050. We have discovered vast reserves of coal, gas and oil that have developed over millions of years and burned them, loading the atmosphere with CO2 levels that have caused multiple climate extremes in the past 100 years. Our society has grown in complexity and it's extremely dependent on fragile utility systems. All these factors increasingly expose ourselves and our communities to disasters. There were over 7,000 recorded major disaster events in the last 2 decades that have taken more than 1 million lives, affected more than 4 billion people, and caused nearly $3 trillion in losses worldwide. The impact of natural disasters is unevenly distributed over the world, with the majority of the impact occurring in the low and mid-income countries, with a dramatic reduction in their economic and social development. However, there has been a significant progress in technology, such as the deployment of multiple and highly sophisticated satellite systems, the development of machine learning and big data analysis techniques. This is enabling us to find new solutions to global challenges, such as climate change, increasing disaster impacts, and the claim for sufficient and secure food, water, energy, health, land, housing, and finding new ways to recover and to heal our home, planet Earth, and worldwide. With this interdisciplinary and participatory approach, we will reinforce and further develop our contribution to make society prepared for disasters and to ensure that new generations can live and grow in safety towards a resilient and sustainable future. To find out more, please visit our website.
Okay, after this brief introduction, I think we we would like to develop tools that would reduce risk, and in order to do that, we need decision making on what would be the best risk reduction alternatives and the best strategies. So we would require technology to do that. There have been a number of tools developed over time, but all of them have certain limitations. So they would be either too complex, working for a specific area, they are not available or maintained anymore, or they don't include the options to look at future scenarios or risk reduction alternatives. So with that in mind, AIT Geoinformatics Center, together with us, faculty ITC, University of Twente, we developed our own tool, which is called Risk Changes. This is a tool which enables the analysis of multi-hazard risk in different environments. It is based on spatial data that users can upload either as intensity maps or susceptibility maps. It has a included vulnerability database and can work with multiple assets. So multiple users can use the system and compare risk reduction alternatives for different situations. They can upload their own GIS data and do the analysis in the cloud. So this has been developed over the past years, and it can be run both as an online tool where users can register, they can initiate, they can start uploading their own data, their hazard data as geotiffs and vector data for the elements at risk, and then carry out the exposure, vulnerability, and loss estimation, finally also the risk assessment. Experienced users can also do this using the available Python library. So all the scripts that we developed for this tool are available as Python scripts and can be used also independently, also in a batch mode. So this would allow, say, also a more large type of applications. So it has different components. So the component of data management is very important to generate projects and to upload the data, to evaluate the exposure, then use vulnerability curves to assess the loss, and then combine losses of different frequencies into a risk analysis and use that to visualize. To show very quickly what the system can do, a very small demonstration here. So you could select different types of hazards, for example, that you've uploaded here, an example of flooding, and have information for different frequencies. Hazard maps are not generated in the system itself. Here you see, for example, the losses caused by a 20 and compared to a 50-year return period, a 100-year return period event, which is more severe. And so the more rare the event, also the more heavier the damage would be. You can compare it among different types of hazards, and you could also combine the different hazards into a multi-hazard risk. Then we can use it also for risk reduction planning. So we can compare, for example, what is the current situation if we compare it with a risk reduction alternative like engineering solutions. You see that would reduce the risk significantly, but in some areas more than others. And we can compare it also to other types of risk reduction alternatives. We could also look in future, so we can compare current situation. I think, yes. the current situation with future scenarios, for example, in 2050, how with population growth and climate change, the situation would change, and compare it with different future scenarios. Then we could also compare the alternatives, how they behave under different future scenarios. So in a nutshell, this is a tool that allows to evaluate how risk changes over time for multi-hazard risks. So it has a component that deals with the current level of risk, where we analyze the risk due to multiple types of hazards and see how they would affect the losses and the risk within an area. We would then introduce risk reduction alternatives and compare how hazard would change, how exposure and vulnerability would change, and we would compare that with the current risk. So we have a level of risk reduction, and we could do this with a cost-benefit analysis to analyze what would be optimal risk reduction alternatives. For future scenarios, we can make projections and pathways with respect to land use, with climate change, population change, and make different scenarios where we would say what would be the risk in future for the different hazard types. And we can then also combine the different components, so we can see what would be the best change-proof alternative under which future scenario. And then use cost-benefit analysis, where also the benefits would actually change from year to year. So we have developed the system, and we also aim to apply that in different application fields. And one area where we've been working together with AIT was in Dominica, in the Caribbean, where we developed it also for early warning. I would like to end my presentation with a small video on this.
Tropical storms have caused major damage in small island states. Their intensity and frequency is expected to increase due to climate change. They cause processes such as floods, landslides, and storm surges. Their impact is difficult to predict because the current models are not capable to model them in combination. Many areas don't have the detailed input data, and running them in real time is not feasible. We propose to develop a real-time prediction tool for hurricane impact in small island states through integrated multi-hazard process models with input data that is downscaled using deep learning approaches to give predictions of impact at the local level. We do this by improving free spatial data as model input and run many scenarios for different rainfall events, resulting in a database of simulated hazard and impact maps. When a tropical storm is approaching, the most likely scenario is selected using AI, and the expected impact is communicated. The approach will provide realistic hazard and impact predictions on infrastructure and population, obtained through the use of deep learning to improve the input data on topography and soils. The resulting tool will support initiatives of international organizations such as the Red Cross in making impact-based forecasts for approaching cyclones to take actions to reduce the risk. Tropical.
So with that, I would like to thank you for your attention in this short presentation. Thank you.
Okay, thank you, Professor Case. We appreciated your presentation on risk changes, and it's an interesting platform. I would like to direct the audience, if you have any questions, you feel free to load them in the chat. However, we're not going to address those until after the next session. So we'll have one more presentation, and then we'll have about 10 minutes for question and answers, but feel free to put those questions in the chat and we'll try to get to those. Okay, that takes us to our second presentation now. This next presentation is going to come from Dr. Menzul Kumar Hazarika. He is the director of the Geoinformatics Center at AIT. And over the past 20 years, Dr. Hazarika has been extensively working in applications of geospatial technologies in agriculture, disaster management, and the environment. Dr. Menzul, would you please take the floor?
Thank you, Frank. Let me share my screen. Okay. Frank, can you see my screen? Yeah.
Yes, can see your screen.
Okay, thank you very much. So, although I was supposed to speak first, but Professor Case has some small appointment. He has to go early, so we just switch it, but hopefully it should be fine. So my presentation is application of geospatial data and technology in post-disaster response and reconstruction. And so, yeah. So my presentation contains a very short, brief introduction. Then post-disaster satellite data for emergency response, which we have been using very frequently for this Asia-Pacific region, and also post-disaster ground or building stability for reconstruction monitoring after a big disaster. So let me introduce about our center. This beautiful image is of our campus, very green campus in AIT, many of you know. And this is actually captured by our drone. We have developed few drones in-house here. So we use one of our drones to capture this image. So in our center, it was established in 1999, and it was inaugurated by Her Royal Highness Princess Mahasakri Srindhan. And it will be, and since then, we have been, initially we were started as a training center, but now we are also moving to many other areas. For example, remote sensing GIS application, agriculture application, then disaster management, environment, and capacity building. Still, we are continuing. And this is some of our activities. You can see some training and some of these field work. You can see. Okay. So first, post-disaster satellite data for emergency response. So when there is a disaster or a crisis, then there is a particularly for satellite data. Actually, there is a two kind of organization or two kind of initiatives, I would say. Is the one is for Asia, it is called Sentinel Asia, headed by Japanese Space Agency, and also many other space agencies are involved, including JISDA in Thailand. Then another one is if the disaster is very big, then it is upscale or escalated to international level. Then there's a called International Disaster Charter, which is a in that case, you can get quite a wide range of satellite data all over the world, including from private sector. So then when disaster happens, this mobilization of, there is a mechanism, so you can trigger it, you can activation of Sentinel Asia or International Disaster Charter. Then once you activate it, then mobilization takes place. And then the location of the disaster will be communicated among the space agencies, and then this data, then they will program their satellite to acquire the data of the disaster affected area. And this is a priority job for them. So they will cancel all other kinds of acquisition during that time, just to focus on getting data from the location where disaster strike. Then once this data is acquired, then it will be provided to the data processing centers. So our center in AIT is a regional hub for this kind of data processing. So any disaster happen in this region, through Sentinel Asia mechanism, we get all the data here. And then we process and then analyze, and also we do some data fusion with some other data available, GIS data or whatever. Then we produce map. So these maps are, we try to have some quality control on the map, and we have also, but mostly online, we upload in the websites, our website, as well as Sentinel is our International Disaster Charter website, if we are involved in that particular activity for International Disaster Charter. And also we provided the GIS geodata of the affected area to the other countries or other the affected countries and the other stakeholders. And that's how this works. So if you look at these recent disasters, I think from June last year till February, till last month, there are 24 activations in Asia and the Pacific island countries. And all these activations were handled by us. And you can see mostly 80% or more is actually flood. But surprisingly, last year there are several volcanic eruptions in Japan, Philippines, Indonesia, and also Tonga very recently. And but this is very unusual. Mostly flood and to some extent landslide also we got. We usually get. And if you see here 19, 20, 21 serial number, these three, these are the very big disasters. So this has been escalated to International Disaster Charter from Sentinel. It means that we'll get many more data from both government agencies, space agencies, as a private sector to prepare some good quality product to respond to that particular disaster. So last year, one big one is Sri Lanka. You can see flood, volcanic eruption in Philippines, and also Indonesia. So these are the three major ones we attended. Also, there is a Japan one there, as well as one in Thailand flood. So I will take one example that which we attended very successfully in 2018. There's a 7.8 magnitude earthquake in Sulawesi in Indonesia, which created tsunami, triggered tsunami up to 3-meter height. Almost 844 people were lost their lives, displacing 50,000. And worst affected area is Palu, where 300 people were there. And immediately after the disaster, we got satellite data, and we also, because it was a very big disaster, so we sent our team to the field to collect the data. So these are the with local partners, our partners. We approximately collected 400 photographs during this field survey. And this satellite data, whatever came to us, we processed, and you can see this is one platform we have created, and with these products are, we call value-added products or VAP, and you see this is a tsunami affected area here. And in right side, upper side, you can see this is a liquefaction. You see all the buildings completely gone because of liquefaction due to earthquake shaking. Basically, as many of you know, liquefaction, if there is a groundwater table is high and soil is soft, then because of shaking, whole area become like a mud and everything is gone there. So this is one area. Then also in downs below, you can see some of this infrastructure damage we have identified, and also this along the coast, we could take photographs and this from our field survey with our local partners. So we build this platform after that, and whatever I'm showing here, you can access using this web link, and you can see all this information, many more information on this area. And our products were, because we work with a local government or provincial government, and also a lot of technical agencies together. And our products were very much useful for them. And this is the governor of Central Sulawesi. Backside is our images. So he talked to press, praising our work. Also, Indonesian paramilitary forces also uses our products during this big disaster. The part 2, I'm going to talk about this, the post-disaster ground stability or reconstruction monitoring. This is SAR, synthetic aperture radar, SAR interferometry, it is known as. So this is the technology which can be used to see any changes in the ground. So basically, if you look at this radar microwave, these are microwave from 3 centimeter to 100 centimeter wavelength, and it travel from the satellite to ground. So in this particular wave, you can see 3 complete cycle, and then this remaining rest, this is being used very innovative way to measure the changes in the ground, which I'm going to show you in next slide. Okay, so this is a satellite, and this satellite is sending the microwave and it hitting the ground. Then again, after some time, the same satellite, passed through this same location, but if there is no change, then you cannot sense any, cannot see any detection, any change, or you cannot detect any change, right? So, but if there's an earthquake, suppose, then your ground is subsidized, gone down because of earthquake shaking, or maybe landslide, or maybe land subsidence. Then you can see here the red portion, that is the we call phase. This can be measured up to millimeter level. So imagine a satellite flying 800 kilometer in the space from the ground, but it can measure in millimeter level. So this is a very, very innovative technology. And then this project we are working this kind of data for quite some time. This is one of the application of this SAR interferometry. This is not our work, but this is in Bangkok. You can see Bangkok has a lot of land subsidence problem. And it is SAR data was used to see the land subsidence in Bangkok. Earlier, it was very serious problem, up to more than 1 meter, more than 12 centimeter, right? 12 centimeter per year subsidence used to happen before. But now, as you know, Bangkok government are very strict, and they stopped, put stringent regulation for limiting the groundwater pumping, which causes land subsidence. After that, still it has been controlled to a great extent, but still you have 20 millimeter per year land subsidence. So you can see where the area in Bangkok land subsidence. This is, but this is one of the applications. But again, this same the area in Sulawesi in Indonesia, we have also worked using the same technology, and the first thing which I have mentioned to you about the Sulawesi, that is the before disaster, immediately after disaster, we work under the Sentinel Asian International Disaster Charter. But after that, when disaster happened, then there are a lot of fund has come from many donors, including ADB, Asian Development Bank, and the Asian Development Bank funded this project. And then we also work with Asian Development Bank to see what are the changes is happening. You see, the ground motion map. This is on 28 September, before 28 September, when this the earthquake strike. So you see this green, there's basically green means 0 in the middle, so no change, it is just stable. But immediately after the earthquake, we got the images. You can see this area is going down, this red area, and this blue area lifted because of earthquake shaking. And there's a fault line actually along this from north to south. So this along fault line, there's a big difference. One side of the fault line, it is lifting, another side of the fault line is subsiding. So this is immediately after. Then the technology is such that you can now monitor this kind of changes in the ground every 2 weeks, because satellite data is available every 2 weeks. Then we started monitoring every month actually. So now you see after 1 year, that is 2019, this is the situation. So still some land is not stabilized, it is moving up or down. So you can see these are the, but now after 3 years, say last year, 2021, as I said, we are monitoring. Now you see these are becoming green. It means it's becoming stable or going to be stable. So these are the, as I said, it's a millimeter level measurement. You can see continuously monitoring every 2 weeks. So this is a very important technology, I think, to monitor any changes in the ground in terms of, say, from a disaster, if there's a landslide, if there's a land subsidence, or then you can, or there's a, for example, some river erosion is happening, you can monitor every 15 days using this technology. So this is the overall situation of the ground, but we also look at the building level. So you can see this area along the fault. So these are the building. Red one is unstable. So they are still either going up or going down. I think to become stable, it takes several years because of this geological event. It takes quite a long time to become stable. So we have identified these buildings which are unstable, and we are providing this information. Indonesian government, particularly Minister of Housing, and they are using this information. So this is from SAR data, microwave data. Now we are also looking at the at building level images using the optical data. This like a normal, like a photograph kind of thing. So this is the immediately after the disaster, using Sentinel in terms of disaster starter, there are attempts. We also participated. Can you somebody mute a mic? Okay, so you can see, I mean, this effort with it, but after the disaster, this is we under ADB support, we also did we have done much more detailed analysis. So that's, you can see this building before earthquake, left side, and then after earthquake, this particular building you see completely damaged. Okay. Then some of the buildings were repaired. So here, building damage completely destroyed. Then they replaced by some new building. So this kind of analysis we have done, and you can see the red one is completely demolished, the green one is repaired. Some of these light blue is replaced. The dark blue is completely new. So some majority of the building, of course, there is no damage or nothing happened to them. And then particularly some of the area, as I said, the liquefaction area was completely all buildings were gone during that time because of liquefaction. So this kind of map can be produced, and this is being supplied to the Indonesian government to monitor the reconstruction process within the ministry, because So that is building level. Then also we look at the irrigation canals. This south part of this Palu city, there is a large agricultural fields. So you can see this canals. The red one is completely destroyed. Red portion is completely destroyed. The yellow portion is damaged. The blue one is no damage. And some of these locations, maybe we could not evaluate it because of sometimes, satellite image is not good, or maybe some cloud cover, or maybe some vegetation. We cannot see that. So this has been also done. And ADB is doing this one because they want to direct their findings to provide the information to the Indonesian government, because ADB is also giving huge funding for reconstruction. So they will use this information for reconstruction activities in the Palu city in collaboration with the Indonesian government. Thank you very much.
Okay, thank you, Dr. Manzoul, for that presentation. It's great to see the efforts going on in Palu. I think we all remember when that occurred and how devastating that was. But it's good to see that there's some reconstruction efforts going on and whatnot. Great. That'll bring us to our question and answer session now. If you have any questions for Dr. Manzoul or Professor Case, please go ahead and put those in the chat. We had one question for Professor Case, if you're still available. Is this risk change platform, is it available for every country to do this task? Is it globally available?
Yes, or we cannot hear you.
Professor Case, are you still in the chat with us?
I think he has.
Yeah, he said he had to leave early, so maybe he already got out.
Okay, I can answer this question first.
Okay, great. Yeah, go ahead, please.
I'm also one of the co-developer of this. So yes, this platform is available for the whole globe. I mean, available in the sense this anywhere in the world, this platform can be used. There's no problem on that. But only issue is that data. So if you don't have, I mean, you need some basic data, for example, building layers or infrastructure layers, or you need some, say, if you want to work on identify the flood affected area, then you need the rainfall information, you need the elevation model of that area, you need the river resource to do the flood modeling part. Although this particular platform is not focusing on the, say, hazard assessment, I mean the flood extent or flood depth, but once we have this flood map, then we integrate this flood map with the buildings and infrastructure together. Then we see how much buildings are exposed to flood, and on basis of that, we do the risk assessment. So in that sense, but the good news is that there are a lot of building data freely available, or infrastructure data like OpenStreetMap, which may not be complete, but still you get in some of the countries very good data. And recently, this German space agency, DLR, they have also uploaded the building footprint across all over the world, is derived from their satellite data, and they update this data every few years. So those kind of data is now available globally. So it is very easy for us to use that kind of data to input into this platform. That is current status, but in future we are also bringing a hazard model called OpenListen, which can do your flood model, flood hazard maps for flood modeling, which can do also landslide modeling and debris flow. So this OpenLSM will be also a kind of not in the mainstream, but in the side it will be there. People can use that OpenLSM to generate this kind of hazard maps and bring to this risk changes. I think that answers your question. Okay, now how emergency response system satellite work in the post-processing or near real time? It is actually near real time, I would say, because once satellite data is taken within 24 hours, we have to produce maps. So once data comes to us, we work day and night and produce these maps, and these maps immediately disseminated to the government agencies in the affected country. So earlier it was, we remember it took 4, 5, 6 days to get the map out after getting the data. But now I think it is maybe 24 hours to 48 hours. We get the map and give to the countries. Question number 2, are we able to detect dynamic changes land use in a little larger area? Yeah, I think dynamic changes of land use is not a difficult job using remote sensing, but only problem is that you need to get data. And the data nowadays, honestly speaking, this European satellite data, which I talk about it in Palu, in Indonesia, these data sets are becoming available freely, both optical data as well as microwave data, and that the European Space Agency Sentinel-2, which is 10-meter resolution, this is free data. So using that kind of data, certainly you can monitor land use changes. For example, we are using now to see the crop changes in the crop, maybe every 15 days, anywhere in the world, you can do that now. So yeah, we are also doing that kind of thing. How do you resolve in temporary resolution satellite into the model? How do you resolve the temporary resolution of satellite to the model? So I am not very sure what the question is, but I think what it is saying that if satellite has a one resolution and model has a different resolution, then how you can resolve this issue? I think this is a issue. I mean, you can minimize the kind of error, but you completely, if your satellite data is coarse resolution, your model is high resolution, it will be, you can resample your satellite data to model resolution, but it will information will be lost, right? So it is very difficult, but my suggestion would be that the model what you are running, the resolution should be close to the satellite data. That will be, I think, the best solution for this. So then would you be able to make impact-based coastal flooding or forecasting? So I think this we are talking about risk assessment and response, which when we say risk assessment, we talk about what will happen if this magnitude disaster, as a 2-meter flood happen here. What will be your risk in terms of population, in terms of infrastructure, right? So that we do, but in real time, I think impact based is a real time situation. So once rainfall is happening, then you get the real time information, and then what will be impact, whether this rainfall will cause flooding, or if tsunami is coming, tsunami will be entered to the coast, inside the coast, and cause flooding. So this is a little bit those are nowcasting or that kind of situation. So we are having some system developed, and we are implementing one project in India, but not so many. Okay, researchers tools support basic models of flood landslide, or user need to upload. So as I think I have explained this one. As of now, we are not support modeling, but once you have flood data, then you have vulnerability data. Risk sensors help you to put together in one platform and do the risk assessment. The problem is so far normally happen is if somebody is working on flood, somebody is working on earthquake, another is landslide. These people, they don't understand each other, because flood people have nothing to do with earthquake. So they are always working in their silos, different in their own domain. But when say heavy rainfall happen, you have a flood, you have a landslide together. So in that case, your different disciplines should work together and bring them together in one platform. That is the idea. So in this platform, any hazard, any you name it, everything can be bring together, and you see the combined impact of all these disasters. That is the idea. But the hazard assessment tools, as I said, OpenLSM, our another team is working, and eventually it will be integrated where you can do the modeling for flood and landslide. Whether this model can be shared.
Okay, thank you, Dr. Manzoul. I think that takes us right to the end of our Q&A session. We appreciate you answering those questions for our audience. Thank you. And that is actually going to transition us into our next segment. So we have just completed the disaster management portion of our tech talk today. Now we'll transition to agriculture. And so with that, we're going to go to our next speaker, who is, I have the pleasure of introducing Ms. Sangeeta Dubey. She is the FAO Regional Statistician for Asia and the Pacific, and she has extensive experience in the field of statistics. Her work focuses on building statistical capacity of countries in food and agriculture-related SDG indicators, surveys and censuses, and the use of cost-effective technologies for data collection and dissemination. Sangeeta, the floor is yours.
Thank you very much, Frank. If you don't mind, I'd like to share my screen. I have very, very few slides, and I'll keep my intervention relatively short. First of all, let me congratulate the Geoinformatics Center for putting together this very interesting tech talk, and my sincere appreciation for inviting me. I'm just trying to open my presentation at the moment. If I can't, I will ask Frank if you could share the presentation if this doesn't come up soon, just because I want to make sure I don't avoid taking too much of time to get this up and going. Is this showing up on your screen?
Yes, we have it. Thank you, Sangeeta.
Okay. So the main slide I'd like to talk a little bit about is a future vision for how geospatial data would be used. And we already know that some of these uses occur in certain countries. The most effective use is when the private sector itself is using geospatial data for decision making. And by the private sector, I'm talking about all of the industries that provide inputs into a farm, the farmers' decisions themselves, and how the products from the farms go out towards their final uses, whether it's final consumption or intermediate use by industry. So you can see some examples. The use of survey drones, which is a type of remote sensing, which also relies on links to satellite data to survey fields, map weeds, yield, soil, and so forth. We know that there's already sensors being attached to a lot of agricultural machinery, whether it is tractors or what we're calling here agrobots, whether it's drones, whether the sensors are actually embedded in livestock themselves to monitor livestock health, gestation, pregnancies, delivery, and so forth. This enables, some of these uses enable farmers to make just better decisions on how to deal with livestock disease, on how to orient their tractors, sometimes, again, using these smart technologies, having tractors drive themselves. Anecdotally, I know of a farmer, of a close friend, who runs a dairy farm in Germany, who's now able to actually go away on holidays because these sensors and the use of geospatial data enables the barnyards to actually let the cows out into the pasture at the right time, to herd them back in at the right time. And it doesn't require as much labor-intensive follow-up. Now, of course, some of you are probably thinking, but especially in Asia and the Pacific, the one thing we're not short of is labor. So right now I'm abstracting for what this impact has for labor input, but just talking about a vision of how geospatial data could be used on the farm. Of course, other industries that would use this, and they do currently use this, is to monitor the demand for fertilizers, just looking at soil health. Fertilizer companies can collect that data. Insurance companies often use geospatial data to assess if a damage has actually occurred. And we also hear of situations where banks in the US have been using geospatial data to warn their customers ahead of time of hurricanes that are coming on path, to let them know not only what escape routes they could use to drive away from that ongoing path, but also if the risk is gone. So there's tremendous use of geospatial data at the level of, in this vision, the private sector. There is a very, very strong role, of course, for the academic sector and the public sector, including organizations like FAO, to build the knowledge base, to create the public goods, to create the methodologies that enable this to happen. But this is very much a collaborative approach that requires decision-making on the part of individuals, companies, NGOs, academia, governments, and international organizations such as FAO. To go to the next slide, here are some ideas of what the time horizons for decisions are, because of course, one of the things that drives whether or not the data that comes is timely is how individuals actually plan their decisions when they need that information. So for example, for pesticide application, the decisions are made in periods of days or weeks. For fertilizer planning, it's made a little bit later. For major infrastructure construction, such as dams, it takes decades to plan, not only to actually build the dams, but to actually get information on what the demand is, and not just the current demand, but the future demand. So knowing what types of decisions need to be made, here's an example of some work that FAO has done with GIC in looking at a problem that a country faced, expanding, for example, banana production in Laos, necessitated looking at what the suitable areas were for banana production, looking at different levels of inputs and what the hotspots were. So this actually enables government planning and then advocacy to encourage farmers to either expand their production of a particular commodity or to adopt production of a particular commodity. So what are some of the opportunities for geospatial information? There's absolutely no doubt that climate mitigation is a big, big issue. We've seen how weather patterns have changed food production, how they've created different types and increased risks for farmers. We've seen how specific disasters such as COVID have also impacted supply chains, particularly food supply chains, and what implications they have. What geospatial data enables us to do, hypothetically, is get real-time information at high resolution. Practically, of course, it's not that simple. You all know that, being GIS experts, that there is a lot of work behind the scenes. Fortunately, with organizations like NASA and the European Space Agency making higher resolution images free, with more open source software for processing, with more sharing of knowledge in various venues, including this Tech Talk, that information can be shared. So when we're informing private and public decision-making and actions, there are sector and crop-specific interventions and also insights to deal with things like climate and environmental risk, both from a short-term to medium-term to long-term perspective. There's assessment of crop or livestock damage, both as early warning to mitigate, but also after the fact to trigger insurance payments and accurate insurance payments. And then just the improved integration of data beyond just geospatial data with the survey data that's currently collected from household surveys, farm surveys, censuses, as well as all the infrastructure data that's available. So I want to give you an idea of some of the partnerships that FAO currently has with AIT, and I see these as growing. So we've got this big portfolio of what we call GEF, pipeline projects. These are major projects at country level. They're funded by a group of donors, and these are typically based on climate mitigation, climate adaptation. And the environment is a huge factor, and of course, agriculture as a sector, given its resource use, environmental resource use, is a big part of these set of projects. So these are undergoing, but these are sources of financing. The actual work itself has been in identifying areas suitable for crop-specific production through FAO's Hand in Hand initiative and our geospatial platform. GIC has worked to map agroecological zones in countries to help us look at how to integrate survey census data that's geo-referenced and to produce regular crop statistics, including damage and loss statistics. And one of the things that we're currently looking at, in addition to these areas, is the dissemination of ground truth data as a global public good. The one thing that I hear over and over again as we work with geospatial data is how expensive and costly it is to validate that data through some kind of in situ data collection or other ground truth data collection, which is also used to validate the AI algorithms. But often this ground truth data is kept on individual computers or servers and not disseminated in itself as a good, which means that it can't be reused. So we're working with AIT to see how ground truth data collected by various organizations, whether they be researchers, government organizations, private sector firms, how we can create basic guidelines and a platform to disseminate and share this ground truth data so others can use it to improve on algorithms and for potentially to use it for other purposes in producing different types of geospatial information and analysis. So with that background, I will pass the mic back to Frank. Thank you.
Thank you, Sangeeta, for that very concise but also very important talk on geospatial information in the agri-food systems. So I think we heard about some great points there for the private and public action, as well as what's going on currently with FAO and GIC as well. So thank you so much. Audience, if you have any questions for Sangeeta, please send those to the chat or hold on to them. We'll have a Q&A session, but it won't happen right now. We're going to go through a couple more speakers, a couple more presentations before we get to the Q&A. So I'd like to get straight to the next speaker. We're still in agriculture here. And our next presenter is Professor Rajendra Shrestha. He's a professor at AIT School of Environment, Resources and Development in the Department of Natural Resources Management, and he specializes in natural resources and conservation. So Dr. Shrestha, the floor is yours. Please take the mic.
Thank you. Thank you, Frank. Can I share the screen?
Let's see. Yep. Please share your screen. Yep. Okay. We can see your presentation.
Thank you. Thank you once again, and good afternoon from Bangkok. My name is Rajendra, and I work at AIT. Also, thank to the previous speaker, Sangeeta, who gave excellent background to the talk I'm going to make. And indeed, I'm going to actually touch upon only one of the initiatives where she mentioned at the hand-in-hand initiatives, among few others that we have been working together. Just a bit of background to the colleagues who are attending here about the issue of food security and the talk on the agroecological zoning, which I'm going to talk today. All of us, we know that, how geospatial data and geospatial technology are useful in various sectors. We have heard about even very, ground level agriculture or insurance or disaster and so on. And talking about food security, as we know, land is the major source of food production, and 50% of inhabitable land surface are under agriculture. And we also know that, we are able to achieve tremendous increase in the yield in last 50, 60 years. and that has been serving our food to the population, which has been increased maybe more than double in last 50, 60 years. Now, on the other hand, if you look at the arable land, it has hardly increased 7% in 50 years. So that is saying that we don't have any more land to go for agricultural expansion. Okay, that there is a very limited land resource available. On the other hand, we have the host of the problems. Talk about land degradations, as we know that a lot of people are living in the area which has been affected by the land degradations. Probably 1/6 of the whole population, they are trapped in this degraded agricultural land, in those kind of landscape. If you only look at the economic cost of land degradation, that is huge, maybe 10% of the annual global gross products or the hundreds of trillion dollars. And we have issue of biodiversity. More to that, we are also facing a lot of land conversion. There is a competing use. We are losing good fertile agricultural land to other uses. For example, settlement, urbanization, industry, livestock, biofuel production, and you name it. The recent study, which has just been published, it says that lately, in last 15, 16 years, they have found that actually the arable land has increased about 1 million square kilometer, and then it is coming from about 50% is coming from the using the natural vegetation areas, for example, forest and pasture, and 50% of areas are actually recultivated. Those abandoned land which were abandoned for some time now, people are recultivating because, again, this also reinforced the fact that we don't have any extra land, to put for the cultivation, while food security remains big issues. As people have been now predicting that we'll have 10 billion people by 2050. Now, so Frank, can you mute all participants? So the need for proper planning about how to use land properly has been recognized for a long time, and then many organizations have been working, and FOA is one of the earliest pioneers, by bringing the lot of land evaluation methodology. For example, land evaluation framework, which was published as early as in 1976. Now, the purpose of such kind of various methodology is to identify and allocate land uses to sustainably meet the various human needs. And among several such land evaluation guidelines and methodology, the development of a specific methodology I'm going to talk today is called as Agroecological Zoning, and that started back in 1978. So basically, this is a methodology to assess the potential of land for agricultural uses for present and future conditions based on the land suitability, potential production, and environmental impact related to biodiversity, climate change, and land degradation. So this basically gives the areas based on their potential and the constraints so that we can do better agricultural land use planning. The justification is that because the land varies from place to place, and so is the socioeconomic situation, policy, the needs and aspirations of the people. That means we need to use the locally available or local geospatial data to better address those planning related issues. Okay, so basically AEG has a lot of these modules, which I won't take time to describe all that. So this is very specific, comprehensive methodology available. We actually have done a lot of basic study on that. Just to give you a quick history, by 1995, actually, learning from the experience and testing this methodology in many countries in Africa, in Asia, that there was a common consensus that we should have a global methodology. So the countries who do not have their own capacity, who do not have their own database, would benefit from that global methodology. So so-called this global agricultural ecological zoning that started back in 1995, and it has been, continuously developing. And by today, we have the GAIS, or Global Agroecological Zoning version 4, and we actually have started to work for the Global Agroecological Zoning version 5. And the reason being only to address the weaknesses in the previous version and to accommodate the additional need. For example, future prediction related to climate change, biodiversity, ecosystem services, and so on. Yeah, the GAIS work has been very much well, appreciated. And as I said, it has continued to evolve. And recognizing that, the value of GAIS, UNCCD has included GAIS as the LDN tools. LDN stands for Land Degradation Neutrality, tools for the land potential assessment and the stratification. Now, as I said earlier, we actually did the studies because in the last 40, 50 years, we have the methodology available. In the early days, it was not necessarily, people use geospatial data and the technology because, as we know, the availability of geospatial data was, very scarce that time. Technology itself was a very infant stage regarding remote sensing technology or GIS technology or GPS, etc. So we did, kind of comprehensive desktop study. So we have found that many countries are actually using this methodology in one way or the other in line with the agent methodology. So you can see in this chart, there are several countries around the globe. Somehow they are working to evaluate their land potential using this methodology some way. Or it was also found that they have been used in many different sectors. For example, land management planning, addressing food security issues, and agricultural development, policy formulation, water management, environment, ecosystem, and so on. So just to give you an idea that, what has been the work done, specifically, this is the snapshot of the GAIS version 4 data portal. There is a link here if anybody wants to check out. And, this is basically the agroecological zoning methodology that has been followed at the global level. So any country can easily get the result, looking at those menu and selecting those menu for the countries for different options available, and they can get the result. Now, that is not only the story. Story is that we should be able to make use of such kind of methodology at the country level so that, we have better tools, we have better data for our decision making at the country level. Now, this is an example again with the partnership with FAO that we have recently completed something called as Land Resource Information Management System. And this is also based on the AEG methodology, as you can see here, AEG data and a lot of other outputs we can generate from this, wave interface, online database for Afghanistan. So we are hoping that, many countries will come forward in having such kind of tools and the methodology. Now, the main story of my presentation today is that, there are the data available at the global level. There are data technology available at the national level, but how to put them together in a very simple, customizable in a way so that countries have their own capacity to work at the national level or at the, even the state or province level, okay, or even the watershed level, depending on the data availability. So this is what we work on as we call as the PyAEG, that is the Python package for crop suitability assessment. So this is user-friendly and this is customizable, which contains the series of algorithms following the AEG methodology, as we have seen earlier in one of the slides. It has specific modules. So we follow that methodology, but write the program in the Python package, which can be easily customizable according to the context of their own, national data. So it has all those modules, as I mentioned here: climate regime, crop simulation, climate constraints, soil constraints. These are the standard modules in AEG. And, there is a possibility that the user can plug in your data, your relevant local data into the system and they can get the result. If not, and it can be used the global data already available in the system. Now these are just the technical, the structure of the PyAEZ. It is open source actually. So this is available in this all the source code, sample data, documentations. All they are published as open source in this repository in GitHub. So basically, this is the NumPy-based library with all algorithms separately written to represent those all modules. Or if you are familiar with the agroecological zoning methodology, and available as the open source package. We are actually, further working on it to improve some of the methods that are locally suitable to include more data. And even we are thinking of, to write some of the, globally used the routines into the PyAEZ that we have been now discussing to improve upon. So these are just a snapshot of the output that were produced using PyAEZ. It was done under the partnership with FAO and GIC. FAO was supporting the work. And then we also actually had a lot of training, training to the participants from Asia and other regions. And we also conducted some of the trainings. If some of you are interested, then it is possible to have this kind of further training. So this is not only the one output, there could be a series of outputs as explained in the methodology that can be produced and that can be displayed using other interface in the GIS. Okay. So at the end, we would like to thank to the partners. They are the experts in this sectors. For example, we work with the ESRI, who is one of the major player in geospatial data. And we also work with FAO for sure, and a top research organization who has been working in AEG for last 25 years, that is ISR. So all those experts, those organizations, we are trying to work and then to refine and to further this PyAEZ work. With that, I would stop here. Thank you.
Okay, thank you, Professor Shrestha, for your look into agroecological zonation. Definitely a big topic. It's as you said, it's been going on since the late 70s, but it continues to be huge for agriculture and even moving forward with climate change and its effects on agriculture. Thank you. So if anyone has questions for Professor Shrestha, I ask that you hold on to those, or you can add them to the chat, whatever, but we're gonna have one more presentation before we get to our Q&A for this agriculture session. So our next presenter is going to be Mr. Lakmal Deshapria. He's a research specialist here at the Geoinformatics Center at AIT. His background is in computer science, and he specializes in geospatial analytics, large-scale mapping, and applications of geospatial technology to agriculture, the environment, and disaster management as well. So Lakmal, with that, the floor is yours. Please share your screen and your.
Thanks, Frank. Let me share my screen. Can you see my screen, Frank?
Yes, it looks like it's loading. I see it's black right now. Okay, there we go. There's your presentation.
Okay, thanks, Frank. So I'll talk about one of our new projects that we have started in the last year. So it's about weather index insurance, and so it's just still behind the early stage of the project. So far it's been a very nice learning experience for us. So I'll mainly talk about what is weather index insurance. So after that, I'll briefly talk about our project. So usually, like in developing countries, so many farmers are living under the poverty line. So poverty line is defined by the World Bank. So $5.5 per day. That means 165 baht, around 165 baht per day. So usually farmers, they have like their yield goes up and down every year, but they can manage it if it is not that big. So once in a while, like every 10 years, they hit with a big disaster like big drought, then yield drastically drops. So it's very hard for them to come out from such a disaster by themselves. So having this kind of insurance help them to come out of such kind of large disasters. Other thing is like farmers live season to season, right? So they get the income from one season and they invest in the next season. So if this cycle breaks down, it is very hard for them to come out of this cycle of poverty. So it's important to have some sort of safety net like agriculture insurance, so that plays a vital role in agriculture economy in developing countries. So usually, traditionally, there are lots of insurance in developed countries in Europe or North America. So they are based on what's called indemnity-based insurance. So basically, like in Germany, so usually the agriculture officers visit the field like 3 times at the beginning of the season, middle of the season, and end of the season. So if they observe some sort of a damage, and they compensate farmers for that one. But the problem with this kind of insurance scheme is these field visits are costly, right? Ultimately, this need to be paid by the customer, in this case, farmers. So this leads to high cost, and premium will be increased, and it becomes more not affordable for the farmers in developing countries, which holds small scale lands. So to overcome this issue, so weather index insurance schemes provide some sort of alternative. So they use weather index or weather data as a proxy to estimate the damage in the field. So this eliminate field visits, and then they can estimate the yield from the weather data. And then based on that damage, estimated damage, farmers can get paid. So this eliminate the field visit cost, and it leads to reduction of premium. Then insurance will be more affordable for farmers. So that's the whole idea of weather index insurance. Another key point about weather index insurance is compared to traditional insurance, their claim settlement period is very low. It's a few weeks, so compared to the few months in traditional insurance schemes. So this helps then if some disaster happen in a particular season, so farmers can get the claim and invest in the next season. So this claim settlement period is pretty low, so that make it very attractive. So how do we design weather index insurance? So usually we collect historical weather data and yield data, and try to establish some sort of relationship between historical yield data and weather data. And after that, they come up with the payout scheme. So in this example, so this is developer drought, and in a month of May as example, so if the rain goes down 20 millimeters, the payout, that means droughts, right? Then the payout will start with 850 rupees. And in worst case scenario, the rainfall will be no rain, 0 millimeters. In that case, farmers get 8,500 rupees. So in between that rainfall levels, so they linearly interpolate between min payout and max payout. And next, so how they decide the premium? Usually they allocate 70% for the basic risk, weather risk, and 20% for the administrative cost, 10% for the profit. So you can see that the big part of the cost is allocated for the basic risk. So that's what makes them more attractive. So administrative cost is pretty low. Right. And so basically we need historical data for 30 years, rainfall and yield data, other weather parameters. We need functional weather stations around farmlands, and we need local agronomy support to understand the local context and the agronomic characteristic of the local crops and so on. So usually getting this weather data is a little bit tricky. So we need 30-40 years historical data. So it's very hard to get continuous data sets. So basically we replace those missing data with satellite images. And so usually there are satellite products, they goes back with their coarser resolution around 5 kilometers, but they go back to 30-40 years back. So we can see in this case 2001 and 2008 drought, which was pretty big in Tajikistan. So we use this satellite data to fill the gap in the meteorological station data. So seems like designing a weather index insurance is the easiest part, and selling insurance to farmers is the hardest part. And so usually in developing countries, farmers has very bad experience about insurance. And so they think these are luxury items. It's hard to get claim from them and so on. So they don't believe in insurance. So selling this insurance product to farmers directly is a little bit tricky. So we need some clever marketing instrument to educate farmers about this insurance scheme. At the same time, most companies, they don't directly sell to farmers, so the sales, distribution, and marketing cost is pretty high. Then again, it becomes not affordable for farmers. So what they do is they try to bundle it with existing sales channels like agriculture loans and agriculture credit schemes and government seeds and fertilizer programs as add-on. So when farmers get loans, this opt into these fertilizer programs, so they can get agriculture insurance as an add-on if they prefer. So that make it more easy to sell these agriculture insurance products. So finally, I'll talk about a little bit about our current ongoing project. And so we are working in the Tajikistan. So in case of Tajikistan context, so the quarter of their GDP is coming from agriculture sector. That's a pretty big deal. And more than half of the employment is also in agriculture sector. That's very high compared to other countries. But surprisingly, they don't have any agriculture insurance scheme. And so historically, so they used to be part of Soviet Union, right? And they get independent in 1991. So before that, they used to have what they call the planned economy, right? Centralized economic system. So the government used to have mandatory insurance scheme. Then after they get independent, so the privatization has happened and the private companies come into the industry, but still they couldn't provide any agriculture insurance in an affordable manner. So UNDP want to tackle this problem and try to look into the alternatives like weather index insurance. That's where this project started. So the summary, so again, so money come from the UNDP, Tajikistan, and it's called a feasibility study for the weather index insurance for Tajikistan. So AIT, we are the lead partner of our project group, and we are working with the Sri Lankan insurance company called Sanasa General Insurance. So these guys are the leading index insurance provider in Sri Lanka. So they have insurance scheme for rice, tea, covering hundreds of thousands of farmers all around Sri Lanka. At the same time, we are working with the Department of Agriculture in Tajikistan to get support as agronomists and get the other historical yield data and so on. At the same time, we are working with the Hydromet department also to get the historical data and so on. So basically, what we are doing here there is like we try to assess their current situation, do a little bit of market analysis, supply side and demand side both. So we do a little bit of farmer surveys and so on. Then we are developing a pilot study for 5 weather stations and for 2 crops in cotton and wheat. We are focusing on cotton and wheat. And as a foreigner, we cannot go there and sell insurance, right? So we are working with the local insurance companies and agriculture companies to implement this insurance after feasibility stage is finished. So as I explained, so we are focusing on cotton and wheat. And so in Tajikistan, they have mainly 2 valleys, so the north and south. So north part is called Suk region, south part is called the Katlong region. So we are focusing on this southern valley, Katlong Valley in Tajikistan. We are focusing on this 5 meteorological stations. And as disasters, we are focusing on drought, excess rainfall, and high temperature, which is a very big disaster there. These are the study areas. So we are focusing on cotton and wheat, that's their distribution maps and the irrigated area maps. So under irrigated area, we are designing our insurance scheme for the droughts, and other areas we are designing our insurance scheme for other disasters such as high temperature events and so on. Yeah, that's it from my side. Thank you. Thanks, Frank.
Thank you, Lakmal. Appreciate your presentation on weather index insurance. And now would be a good time if anyone from our audience would like to engage the speakers from the agriculture session. We had Lakmal with the weather index insurance. Professor Rajendra was telling us about the agroecological zones, and Sangeeta was telling us about some innovations, how we're using geospatial data in agriculture these days. Looks like we have a few questions. The first one is for Professor Rajendra, and I don't know if you can see this one, but I'll read it aloud for everyone. Where can we get the AEZ guide? And they provided, okay, maybe that was answered already. Okay, so yes, so they're asking for the AEZ guide. Okay, another one from Jitaram Asset Company. Can I apply geospatial data and technology innovation in part of sustainable bioenergy forest resources in the future? Use of PIAZ looks interesting, for example, and please give advice if need to GCF SAP funding proposal. So that one sounds like it's for Professor Rajendra. It's sort of addressing the PIAZ tool there. Professor Rajendra?
Thank you. Thank you. Thank you, Frank, and thank you, Jitaram. Sorry if I mispronounce your name. Yeah, I think it is possible because we need to understand when we are doing agroecological zoning or, for that sense, any land evaluation methodology is to compare the constraints and the potential of the land. Now, in terms of the soil and climate, social, economic situation at the present, and also even we can model the future. Of course, we need the data for that. So that said, as long as we know that what kind of crop you are evaluating to find out, what will be the yield potential, etc., it is possible to use. So it is not only for the crop, what I mean, okay? Be it any kind of vegetation, it can be for the rangeland, pasture, the orchard, or the crop, like annual crop, or even the forestry. So the evaluation methodology can be used. Yeah, that is in short. If you have a specific question, I put my email there, and I actually have colleagues whom I have to thank. Probably they are here, and he's going to speak. He's Dr. Kavinda, Ashwan, and so on, who helped me prepare that slides. So my email is there, rajendra@AITCS. So if there is a other question, and I would be happy to respond. Yeah, thank you. And about the AEG guide, yeah, again, let me know what is exactly the question. If it is about the publication, I probably can send you the copy or give you the site from where you can download. And if it is about the PyAEG, then it is available as open source. I can give the link again. Yeah. Thank you.
Okay, welcome back from the break, everyone. We'll just jump right into it. This is going to be our third session of this tech talk. So I'll be getting to the plastic pollution part today. And so our next speaker is going to be Ms. Kakuko Yoshida. She is the Global Coordinator of Chemicals and Pollution Action Subprogram of the United Nations Environment Program. Was previously the Chief Technical Advisor for Phase 2 of the Countermeasure Project. She has extensive global experience with projects involving environmental assessment, air pollution, chemicals and waste management, conservation education, and environment and health. So Ms. Kakuko, the floor is yours, and would you please share your presentation when you're ready?
Yes, thank you. So, okay, let me share my screen. It seems like I don't have the right to share screen. Do I have it? Okay. I don't see yet the shareable. Okay, I see it now. Sorry for the technical hitch. Okay, I trust that you can see my screen now.
Yes, we can see. Thank you.
Excellent. And how is my sound? Is
Yep,
it good enough?
We can hear you fine.
Okay, excellent. I'm speaking to you live from a hotel room next to Tokyo Station in Japan. I landed a few hours back after almost a day and a half traveling from Nairobi. I can do this because all the digital technology has helped me or hindered me along the way. Like, for example, getting through the new COVID procedures took about 3 hours. You know, some of the aspect of the new procedures that the Japanese government have put in place obviously have been helped and enabled because of digital technology. But, you know, sometimes that the QRS code doesn't work, and, you know, that when you try to connect to Wi-Fi, it doesn't. But that's the reality. Now, that reality of digital world has enabling us to tackle one of the maybe the most newest problem that environmentalists are tackling at this moment, which is plastic pollution. And I have a great pleasure to share with you some experience that we have had in the last few years and where we are going with the fighting plastic pollution as part of our Beat Pollution globally, pollution-free planet effort as United Nations Environment Program and its partners. Plastic pollution. Okay, now my screen is not moving from my side. Okay, let's see. All right. Okay. So plastic pollution, I say it's one of the newest pollution issue, but it's maybe potentially one of the biggest that we see these days. I have been in this business of environmental conservation for more than, safely I can say 25 years. And when I talk to my peers who have been around the topic of environmental governance or conservation, they say this is the newest wave or one of the biggest wave after climate change, which really the fighting against climate change started to happen at the global community level about 3 decades ago. So when United Nations Environment Assembly back in 2017 took one of the first global resolution to look into the issue of marine plastic litter, originally started as a marine litter issue, but then quickly it evolved to marine plastic litter issue and then become microplastic issues. And then in the UNEA, third UNEA, Resolution 7, and then the fourth UNEA, Resolution 6, have established ad hoc open-ended expert group so that the global community, government, NGOs, private sector alike could start looking into, and also scientists, very important, could really look into the aspect that really need to be looked at if we are serious about fighting this new form of plastic pollution. But when we say new, the scientist community will laugh because some of the scientists, like for example, Dr. Jambeck from University of Georgia, have been looking into issue for decades. It's just that the global community as a whole or society didn't catch up to this issue until quite recently. And then just less than a month ago at the UNEA 5.2, a global milestone was reached to our common effort to fight plastic pollution. This resolution is so new that it doesn't even have the official the numbering for it yet. It's a new UNEA resolution toward an international legally binding instrument. What this resolution say is say that as UN Environment Assembly, with all the countries, it's a universal membership now of UNEA, agree to start the process toward creating an international legally binding instrument to control plastic pollution with aim to one day stop it completely. addressing the full cycle of plastic value chain. And immediately an intergovernmental negotiating committee, we call INC or INC, will be established to commence its work during the second half of 2022. And it has to finish its work by 2024. Now, for INC to start, smaller, more focused ad hoc open-ended working group will be commenced starting already before the half of this year. And key substantives of the paragraph or work area that this group need to look at is particularly what and how to stop plastic pollution. So on what, they have to discuss about objectives, sustainable production, consumption, how to create action plan at the country level so that each government and civil society stakeholder alike will come to agreement on a plan to stop first, measuring how much plastic pollution they have most likely, and then identify the remedial action and schedule so that each country will have obligation to set up their own plan to reduce plastic pollution. And of course, once what is the aim is established, then how means of implementation come into picture. So in this work area, obviously, they will discuss about what kind of policy is necessary. Socioeconomic information assessment should be done on the plastic pollution. And also, if this global instrument is work, what kind of secretariats need to be established to oversee its governance. And it has this resolution already stipulate it's very important that new global instrument, some people already call it a new treaty, should abide by real principle and of the national circumstances and capability so that everybody have responsibility to contribute to plastic pollution, but they may have differences in the capacity to meet their national obligation. So the support should be given. And also it should be a platform, partnership platform, where the existing initiative to fight plastic pollution and also the opinion of different stakeholders could be expressed and information can be exchanged. Now, UNEP, starting this year, 2022, we are embarking on the new 4-year medium-term strategy of our operation globally. Now, within, we have a brand new sub-program called Digital Transformation. Now, in this digital transformation, we have 3 aims. 1, digital ecosystem of data for the planet is enabled through the digital engagement of UNEP. Also, with use of digital technology and transformation, we will shift the market and consumer behavior. And lastly, we would like to contribute working with partners like Asian Institute of Technology and many others to promote digital literacy. We know that there is a digital divide. As I said, there were a lot of benefits brought from the digital transformation technology already available, like many socioeconomic aspects of our society. The availability, the opportunity are not equally distributed geographically and also among the class of our population, global population. So we would like to contribute to reduce that inequity on the digital literacy and also the contribute to the innovation and e-governance that require to use the digital technology and opportunity fairly. Now, what does that mean in our fight against plastic pollution? Number 1, I believe it means that we're going to have more data and information to create our policies and take action as groups, private sectors, and even individuals. For example, we are now starting new partnership with Mindaru Foundation and their technical partner to build on their work already existing, using the satellite imagery, breaking down to the individual pixel, and really use that to monitor how dynamic change is, what kind of dynamic change is happening around the open dump site and landfills. We do this because we already have our own studies and with partner that the dump site, open landfill, if they are not managed, and particularly if they are very close to the waterways, canal or coastal area, often they are, if they are close enough, and if they are not managed properly, then they are very important plastic leakage sites. So monitoring how the behavior and dynamics of the dump site, open dump site, landfill is something very important to for our fight against plastic pollution. Unfortunately, like for example, we do every few years, we create a new assessment called Global Waste Management Outlook. We have done already one, global one. The second one is being finalized right now. But every time when we do this kind of outlook, major problem is availability of data. Now we know that information about waste management is one of the most scarce when you try to do an assessment on the state of environment, and relying on official data coming from municipal level or the private sector individually will never give us a complete picture how we are dealing with waste. So using the satellite image with the artificial intelligence analysis like Mindaru Foundation and their tech partner doing is extremely useful. Maybe one day we will be able to get more complete coverage of the waste management status of the world, which will help us to do more precise plastic pollution management action plan and strategy globally and also at the national level. So the image you are seeing right now is one of the dump site or landfill site in Indonesia, and how the area where the landfill is filled with waste is expanding. Another reason that we think the digital transformation will be useful for our fight against plastic pollution is this. Now, I occasionally see the YouTube channel, and my 13-year-old son often introduce me to the type of site that I don't voluntarily go into. One day we stumbled upon this YouTube channel. I gave this landlord homeowner a free makeover long cut, time lapse of the crazy yard cleanup. And I said, you know, who look at something like this? This is crazy. You are just somebody, you know, watching somebody clean up somebody's yard and grass cutting, the cleaning happening in a time lapse. And then I look at it. This has 10 million or some of them have 10 million viewers. Some have a 1 million viewer. So I say, okay, so people do watch this kind of stuff. So that gave us an idea to do a time-lapse image through a CCTV camera set up by Asian Institute of Technology in the upper part of Mekong River in Thailand, so that people can watch through our CCTV camera how much plastic pollution is accumulating in one section of Mekong River. And guess what? We did this as part of a Clean Sea 2.0 global campaign, as well as countermeasure 2, the outreach campaign. Now, this live footage of the time-lapse image was one of the most successful activation we have done so far under the global campaign. So, bottom line is that digital technology is part of our society, and to fight our contemporary environmental issues such as plastic pollution, we would definitely embrace it. Now we know that another aspect of environmental problem that digital technology is bringing is e-waste. and its increasing volume and active trade. But that would take us to another webinar on a topic, which I would be very happy to join if that happens in the future. But hopefully with this, the technology embracing, we will be able to continue to collect better data for action taking and also change perception and behavior of consumer. Thank you.
Thank you, Ms. Kakuko. That was some great applications of geospatial technology for detecting plastics. Very interesting, and I know our audience has some questions to ask you, but we're going to ask them to hold those until after the next presentation. So we'll have one more presentation and then a question and answer session. So our next presenter is Dr. Kavinda Gunasekara. And he is the Associate Director here at the Geoinformatics Center at AIT. And he's also an affiliated faculty at the School of Environment Resources and Development at AIT. He has been involved in implementing geospatial related projects in South, Southeast, and Central Asian countries for the last 15 years. But most recently, he's been the project lead here at GIC for both phase 1 and phase 2 of the countermeasure project. So I'd like to turn it over to you, Dr. Kavinda, and the floor is yours. And please share your screen and presentation.
Thank you, Frank. Let me take over. Yeah, good afternoon to everyone. So I'm going to continue. I think Kakusan nicely put the foundation. So why we need digital solutions and how we can make it innovative to tackle this plastic litter problem. And we are looking into more into detail, like city scale. So myself and countermeasure P-litter team at Geoinformatics Center, combining this all geo information technologies to tackle this problem. So let me go through the our story about these P-litter initiatives. And I think when we're working on this countermeasure project funded by UNEP, so we start to see more cases. Like I think you also quite aware about plastic pollution around yourself. So I brought 3 cases for your attention. And so in the leftmost one, this is my personal experience. So I was able to collect over 200 rubber bands. You won't believe, in 30 minutes, in 30-meter stretch of a beach in Rayong, Thailand, during a cleanup activity organized by MPA program, Marine Plastic Abatement Master Program of AIT. And I think this is the middle one that Kakuko-san mentioned. So one of our branch is CCTV-based monitoring of plastic litter. So this gave you attention globally, what is the seriousness of the situation. If you closely see this times lapse, so we are producing 1 week in 1 minute, and you can see the garbage bag is floating and mattress is floating, and all the items really should not be in waterways. I think as a citizens, we have also a responsibility to help to overcome this situation. And I think this is really useful to make it awareness, social awareness, for people to think to help to reduce plastic pollution. The rightmost one is interesting photograph. And our team is coming from geoinformatics, GIS related activities, and that is our experience. You can see that 2 sides I demarcated. One side is belong to municipality A, other side is belong to another municipality. You can see the side A is very clean, side B is very polluted. And I think we start to think about maybe municipality A could be having proper cleaning activities, maybe B. Maybe that's very difficult to say this, looking at one photo, it's very difficult to assess this situation. It could be effect of the wind and there's a barrier in the middle. So to understand this situation, then, and also to make evidence-based policy decisions, so we have to think about continuous solutions, continuous monitoring solutions. So that was the, I think, key motivation for our team to formulate our concept around digital technologies to solve this problem. So I think when we think about this kind of solutions, we can bring latest technologies like machine learning, deep learning, and together with like AI solutions. And to monitor this situation, we can think of IoT, and even can embed CCTV into these IoT solutions. And when you're thinking about scaling up to other countries or having a centralized processing system, so we can think of cloud computing. And always, I think I'm not going to talk, big data is the topic, like if you're getting continuous data, then we have to think about how we're going to analyze this, what we're observing in the environment. I think maybe you may have not agreed to the citizen science, why we are putting this one as a technology. So our team considers citizen science as a technology, because definitely if you want to scale up this kind of solution to around the globe, so we need to get the help of citizens to scale up this solution. I will talk this one in the coming slides. Obviously, I think you may have heard that our mobile network technology is improving, 5G, 6G. If you have this kind of new technologies, data transmission is becoming very easy to scale up this kind of solutions. And when we think about this whole story, then we have to think about ecosystem, how we can build this solution. I think I adapted this one from UNEP document. So as Kakuku-san mentioned, so they are moving into digital transformation and global level solution. And we can divide into 4 sections: data, infrastructure, algorithm, and analytics, insight, and applications. As our concept, we always keeping our data open and always try to keep analysis ready data. So if we done some analysis, we are sharing openly analysis ready data. So people not should repeat that kind of thing. Because of the limited time, I will take only one point from this section. When it comes to infrastructure, if we have open data policy, so we can think of centralized data lake, and then we can communicate with APIs to other stakeholders if they want to scale up. When it comes to algorithm analytics, this is quite important. Nowadays, everyone looking for transparency, how their analytics has been made. And in this case, we also promoting open algorithms and sharing people to use it. And even this PLITA initiatives, you can access our algorithm. It's open source. We will provide the links at the end. And whatever the infrastructure, data, algorithm, analytics we have, then we have to make it insight and which can link to the applications. So how our observations and finding and insight can lead to actionable information. So that is the part we are considering as well to build this solution. I think even in the title, you may have read about this, what is PLITA? I think PLITA is the initiative from Geoinformatics Center, leveraging geoinformatic expertise, what we have together with computer vision and AI to tackle this issue. And we trying to achieve success through our 3M concept. We have man, machine, and mapping technologies. So this is the complete concept of PLITA. And I would say this PLITA had got a good, nice shape because of the countermeasure project. This complete package, we start to compile in countermeasure phase 2. Phase 1, I think we try to use these tools. Then we start to build as a portfolio. So that is the way forward now we are working on. So I'm going to talk about inside of PLITA now. So far we have 4 main components. We call it PLITA Street, PLITA CCTV, PLITA Aerial, and PLITA Mobile. PLITA Street, we fix cameras into vehicles and then it running through the machine learning framework, we can develop plastic litter heat map at city scale. We can identify the number of objects. When it comes to CCTV component, so we are looking into analytics and identify objects floating over the rivers over the time. And PLITA Aerial is, we are starting these activities. We are looking in to make a snapshot of canals using area drones with detecting plastic. And this case, I think we are trying to develop very easy tools to especially avoiding most of the drone data processing framework. So we are trying to develop a solution which people can easily replicable. And mobile components, we have different aspect as well this mobile component, which Frank is going to share in the last part of this workshop. So even mobile, we are deploying to get insight from locations and also trying to improve our machine learning models. Let me quickly go through the P-liter street component. We are executing this work remotely with our partners in the countermeasure project. We make the package of portable equipment and send by post. And we have simple instruction in video guide how they can fix this one to camera. And then if they're thinking about developing litter heat map for city, they can deploy together with the mapping routes. And you can see in this video, these are the items you can see when vehicle is moving. This highlighting items are the litter identified along the street. And below right side, you can see two maps which we developed under the project, which is October 2021, and second one is 2022 January. And we are detecting object along the canal. So I think this is the way we're thinking of how cities can think of how their city is getting better with plastic litters over the time. And also if they want to make a benchmark maps for their cities, what is the pollution stages, they can utilize this kind of tools. So this work is now we are expanding together with other municipalities. Let me talk that one later. And over this 1 year period under the project, we move into different cities. We started with a small case study to test our machine learning algorithms. After that, when you see in the middle, we start to drive about 600 kilometers in Ubon Ratchathani and Chiang Rai cities 2 times to gather data and do the plastic litter detections. And then all the time, we utilize our active learning framework, which is part of the machine learning algorithms. So we see the machine learning prediction of litter, and then we utilize in our framework to see the mistakes and then correct it and then improve the model again. So when we run in through the different cities, our model become more robust. And when the current model is parked at the location, we developed for Macomb, and then we tested in Sri Lanka and Vietnam in Kanto cities. And I think you can see this photograph is very simple. We give the instruction, and even our colleague in Ubon Ratchathani fixing the camera, targeting the litters along the street to travel around. And this is the most important part to understand this complicated nature of litter. I think if we are exposed to machine learning algorithms, you can see nowadays detecting number plates, detecting faces is becoming more easy. But if you start to think about the plastic litter, it's quite complicated. Same object can have a different shape. It can be multiple ways in different cities, and also it can get dirty and then color is different. And also, if I talk about the last point, what is the novelty of plastic project? Like if you think about the mask, you can see when we start COVID, we all start to use the green color mask. But over the time, we start to see pink color and ladies start to use it, and then black color mask. So new products coming into the environment. And in our machine learning model, we also looking into detecting plastic bin to understand and give cities insight how many bins in your area. So even if you think about the plastic bins, there are different innovative ways of making plastic bin in different cities. So these are some kind of snapshot that we overcome. And this is the place we start to think about citizen science approach. When we start to develop, but when we try to scale up, we start to see we have to handle this. Then we start to make citizen science workshop last year, along with the World Environment Day. We try to get inputs from citizens in different cities. We are targeting 2 types of citizens. People can upload an image of litter in their environment to our system, and they can see the model prediction on their mobile phone. And if we have made any mistake in the prediction, they can help us to correct it. And other component, current model, we can detect plastic in general. If it is littering hotspot, we call pile, and then bins and face masks. And we want to go more depth into the plastic categories. So if you know the categories, you can help us to change the taxonomy of the object. And second type of citizen scientists, we are looking in like They can see our model prediction. They can help us to correct it on the computer, like a desktop application. And then over running this kind of solution, then we will get the open source model, which is robust to deploy for cities. In this case, I think we had a partnership under the project with Google sustainability team. To make it more quick prototype, we tested the Google AutoML model, which is quite capable of. I think if you have joined our final workshop, Google now considering the global level applications utilizing Google Street View data sets. And in the project, I think after that, I think we had enough time. We start to train the open source model. So we park our final model in our GitHub repository. And during the workshop, we reached out to over 500 students to disseminate these initiatives and also get the inputs for these models. And also some students from AIT, Marine Plastic Abatement Program, they start to show interest. They want to evaluate really these tools being useful or any difficulty, how to improve. And we had these studies middle of last year, and Pranita, she gave a quite good recommendation to improve our digital tools. So this is the way to adopt into your cities. If you go to this link, you can start to see the GitHub repository where you can experiment. And even it has if you are a little familiar with Python, so you can see the Python notebook, you can execute your data set and see the results as well. And when it's come to now scaling up this solution, so now we want to test different type of cameras, make it cheaper cameras for this model execution and data collection. Now, one student is AIT student working on collecting one municipality data in Thailand, and then trying to detect, like, we think, can we do it 5 days and then produce the heat map for municipality? That is the one way we are starting to experiment. And also we tested some of our mapping tool deploy in Laos, Vientiane municipality with garbage collecting trucks, and then we try to see how this is moving. And also in future, I think we have a good active communication with municipality near to AIT. Can we deploy our mapping cameras into their vehicles, and can we develop the litter benchmark map for the municipality? And I think IUCN start to test three-wheeler to data collection. That is the interesting part as well. Let me quickly go to our CCTV component. And in this case also, we are having the same machine learning framework. I'm not going to discuss. In this case, we are focusing on floating objects in the rivers, and then also how we can visualize these accumulations. And also we are looking into specific dumping locations, and can we develop some insight. And so we deploy these cameras in our Mekong region. Currently, our camera has the real-time transmission. We also capture every 15 seconds images. And also we are building this CCTV module in-house, make it low-cost module for people to replicate. I think you have heard to Kakuko-san discussion. So if this mapping technology is going to scale up and then legally bind all countries, so they have to utilize this kind of solution. So always we are thinking to open our technical know-how for people to replicate. The important part is now we are moving into third camera with real-time prediction capabilities. So left two most are running with the AC power in Mekong Chiang Rai near the Golden Triangle. It's working up to date. So, and the right hand side one is third camera. We're experimenting with in Taklon municipality to detect real-time prediction in these locations. And these are the objects now our machine learning model can predict. And we develop this machine learning model identifying manually, we call it annotation. So from one camera in Mekong region from 15 November to January 4th, you can see that we identify this kind of objects manually, then we start to train the model. So this is something now we are starting to scale up to different cities as well. Let me quickly go through our platform we have. I will take maybe 2 minutes. So if you go to pliter.org, you can see all the solutions at one place. Under this project, we have other component as well. We have, if you want to contribute citizens, you can go to this link. And even we have mobile-based mapping along Mekong region and in Sri Lanka and India. So you can access this all activities in these different components. So leakage mapping, also another component our team is doing. Dr. Dan and other team is leading this part. So to understand and model how plastic leakage is happening and link into the waterways. So if you go here, we are uploading our open data sets into this component. And there are two items are missing. We are planning to scale up this component. Could be from experimenting with the satellite data. And also we are experimenting with the material flow analysis together with the plastic leakage mapping. So those will come in future. Let me quickly go to Street View. If you go to, I'm trying to access, let's try Vietnam. And then Kanto, that is the place we did the testing. And we did this one in January 2022. And this is the heat map developed from the analyzing the videos along the street using machine learning model. So you can see that we have these four type of items that you can see in these cities. If you click into this particular street, then you can start to see our videos and what are the areas that litter is observing. So you can see the below histogram, you can see that the items are more presence in this area. So I think that's why I said we try to make it transparent algorithms, sharing our data, which are using to build these solutions. And also if we start to see some insights, we sharing with evidence so people can see what kind of items we detecting. If you see, just pass some plastic littering hotspot along this street. So this is the interactive one. So I'll already open the CCTV one. Same way you can browse through the CCTV. So this is the CCTV one we fix in Chiang Rai. And these are the objects that we manually identify. So this will be replaced by real-time predictions. We are planning to update the algorithm middle of April. And this is the third camera. And we have a real-time feed if you go to this website. And then this is the automatic detection of items. So after that, it will be all the analytics will be updated in this platform. So we are building this solution. If any municipality, any province, if they want to utilize this one for locally, they can replicate. So that is the place we are looking into this complete single solution. And even you can browse through images under this filtering option in our database. And also, if you go to this storyboard, we are compiling all the activities. This is not completed. This platform, just 2 weeks back, we start to make it public. We are still improving. And then about us, you can see our teammates who are working hard to bring this all digital solutions together with all the technologies for open to everyone to use it. From here, I will stop my talk and I will hand over to Frank. Okay.
Okay, thank you, Dr. Kavinda. I think we have time for maybe one question before we jump to the last presentation. If there's any there, then we can do that. Okay. If not, maybe we'll just jump to the last presentation, and then you can just put those in the chat, and we'll get to those. I think we're kind of coming up on our 4 o'clock end time here, but we got one more. Anyway, this last presentation is going to be for me, your moderator. My name is Frank Earl, and I'm a senior research associate here at the Geoinformatics Center at AIT. And so, yeah, today. Let me load my presentation. Yep. Okay. Yeah. Thank you for waiting for that. So today I'll be going through some outreach and capacity building activities here at GIC. Now, some of these are going to come from the projects that some of the speakers have already gotten into a bit, but I'll try to focus on the outreach and capacity building aspects of it, so not to retread too much ground. And I'll break these down. We're going to look into 10 different aspects or examples of outreach and capacity building from our different projects, and I'll break it down into our disaster management, agriculture, and then our environment type of projects, sort of like we've been following all day today. First, I just want to talk about our satellite-based disaster response. So Dr. Manzoul earlier got into our Sentinel Asia work, where we're responding to natural disasters in the Asia Pacific region. So I just wanted to highlight our disaster response portal, which is located on the GIC website, and you can actually scan that QR code there at the top of the screen, and it'll take you right to our disaster response portal. But basically there we can see yeah, so here we have a map of all the disasters that we've responded to, and these red points are going to be the latest disasters. And over here, you can see in our disaster response portal, you'll find our value-added products. So basically, the products of our analysis of satellite data for the disasters. So here's one from December for flooding in the Philippines. Anyway, that's all available on our disaster response portal online. I'll just briefly mention this project in Tajikistan where we were doing a multi-hazard risk assessment. So here we were doing a hazard assessment for 6 different hazard types, including earthquake, landslide, avalanches, flash flood, drought, and sandstorms. So with that hazard assessment, we were also training some local experts on how to conduct a national multi-hazard risk assessment. So with that training, they were taking the torch on that. And then we also had a composite platform, online platform for a composite risk visualization and analysis, which they later took over as well. Keeping with disaster, this time looking towards the Pacific Island nations in the Pacific Ocean. So here, there was a gap analysis put forth to see what Pacific Island nations, like what they were needing in regards of disaster risk management. And so we identified 8 of those countries to come to GIC here at the Asian Institute of Technology to undergo training with us in GIS, remote sensing, as well as in GeoPortal too. And so from those 8 countries that participated, 4 were able to take on a pilot project where they were able to find the funds for some infrastructure to support the GeoPortal. And so we actually went to these 4 countries and we helped them gather their geospatial data related to disaster, like any kind of like flood data or any kind of infrastructure data, basically. And then we're able to get that going in the GeoPortal, and then they took that over. Another project, this one was across 4 countries, Fiji, Philippines, Bangladesh, and Armenia. Here we're using space technology for mapping and monitoring disaster areas. So this was very citizen science oriented, especially regarding OpenStreetMap. So we were holding mapathons where people would come and map the infrastructure, like buildings in a given city. And then they would go ahead later and add some ancillary data to that, to those files, like maybe the number of floors in the building or the type of building it was. And then later on, whenever there's a disaster, they would take pictures with like a smart device, and then we would bring those in, bring that all together, and then start to make these evacuation maps and then we could implement that with any Sentinel Asia activations or any international disaster charter activations to help better prepare for those disasters. Another one, I believe Dr. Manzoul got into this this reconstruction monitoring in Palu following that disaster. So basically, just to recap, there was we're doing regular land stability and reconstruction monitoring using satellite data there. And so we helped to develop a geospatial platform to support the reconstruction monitoring. So here we're getting these satellite images, we're able to do analysis there as well. And then we can visualize it in the platform too. So like you're seeing here. And so throughout this process, we're training the local experts in Indonesia to carry out all of this analysis as well. So they're going to take this over coming up. And then now shifting towards agriculture, Professor Rajendra got into our agroecological zonation. And so there was, we had one project in Afghanistan where FAO was working with the Ministry of Agriculture there to do a national agroecological zones. And so we came in as part to make an online visualization platform for all that and to look at the current and future cropping scenarios. And even in one of these meetings, we had the Deputy Minister for the Ministry of Agriculture, Irrigation and Livestock come and express how important it is to bring this into Afghanistan, because there's a lot of unused land that with the help of AEZ could potentially find the right crop for the right area, right? And so anyway, this system, this online platform, we're able to hand that over to the Afghanistan Ministry of Agriculture, Irrigation, and Livestock already. So they've got that running now. Another one was with climate. So the Department of Meteorology and Hydrology and the Department of Agricultural Lands in Laos, they're very interested in climate downscaling for food security with regard to climate change and how that's going to affect agriculture in the coming years. And so essentially we trained them, we showed them climate downscaling, and they just took it over. And so they're doing everything on their own now. And then in that, we were using PyAEZ, which we developed here at GIC, which Professor Rajendra mentioned earlier. And so they're, like I said, we showed them how to do it, and they just took it and hit the ground running. They're doing all the climate downscaling, all the processing on the cloud, and they'll have an agricultural atlas, or climate atlas rather, coming out later this year. And here I just wanted to mention some of our drone activities. So we build drones in-house here. And so here's a couple of examples. On the left here is a multi-rotor capable of RTK. And then down here, we're seeing a large bodied fixed wing here, capable of flying about 1 hour on a single battery. And yes, this is good for large scale mapping projects. And we've actually equipped it with a custom parachute landing, which helps reduce the body wear that's of a typical fixed wing body like this. Up here in the top right, this is a new vertical takeoff and landing fixed wing offered by PySat, one company that we're partners with. And so we're looking to bring that one to Thailand soon, and hopefully to GIC, AIT. And also I wanted to mention that we've done quite a lot of drone trainings here at GIC. And I want to say the biggest one that we've done in partnership with FAO, FAORAP. And so this image down here is that I would say that's our largest drone training class for sure. And so we were really happy to host that here at AIT. And I think that was a really successful event. And then almost to the end. So here I want to mention Internet of Things and GNSS. So we've had IoT trainings here at GIC, and also we are developing our own sensors. So here you can see some custom PCBs that we've designed and had made. And also we are making custom 3D printed bodies for these sensors too. So here we're seeing some sensors that we would use for agriculture. Also for GNSS, we were hosting a regional GNSS training course for a few years. It was quite large. We had people coming in from all over the region, and that kind of slowed down once COVID hit. But anyway, we're pretty proud of that. And we also do, we do build custom GNSS receivers here too, from parts as well as 3D printing for the cases. As you can see here, you can see sort of a progression from one of our earlier models to a more sleek, slimmed down version with a touch screen. And finally, I just want to mention, as Dr. Govinda was getting into before in his presentation for P-litter, so part of the countermeasure project was one aspect we were doing was we had a mobile application. And so we were going around and having citizen scientists, so just average people interested in the environment, going to places where litter might accumulate, like artificial barriers, littering spots, or uncontrolled dump sites, which I find all over the place around here. And we had a lot of partners in this project, a number of universities from around the region, including from Thailand, from Laos, from Cambodia, Vietnam, India, and Sri Lanka. So yeah, all this together, this is a snapshot of our dashboard, part of the countermeasure project, specifically related to this mobile app data collection. And so within about a 10-month span, we were able to capture about 3,000 littering spots. And this is in India, Sri Lanka, and around the Mekong River Basin here. So yeah, we're pretty proud of that. We're happy to see the citizen scientists getting involved and that aspect of outreach. That takes me to the end of this presentation. I'd like to thank you all for sticking around, and if you're still here, sticking to the end. And maybe we have time for a question or two, either for myself or for Dr. Govinda or Ms. Kakugo. Thank you.
So maybe no question, look like.
Okay, yeah, that's fine. Dr. Manzoor, would you like to wrap it up for us?
Yeah. Okay. So I think it was a great pleasure to have so many people. I think one point of time more than 160 people were there, and I think a lot of interest in this. And we also see a lot of questions in the chat. So some of the questions are very specific. Maybe I think we can answer some of those. Maybe our organizer, they can save this chat and share it us. We can do, and then we'll try to answer. And secondly, also I have got some. I have seen some of these. People are requesting our presentation. So maybe best way would be maybe we can make a PDF version and put in the Google link, Google Drive, and then send them the link. Maybe our organizing team can do that. So with that, I'd also like to thank all the resource person or speaker, Professor Case, Sangeeta, Professor Sester, and Dr. Mrs. Kakuko-san, and all of my colleagues from GIC to make this event successful. And I believe that this maybe the participants gain some exposure, idea what are the things we are doing. And also I take this opportunity to reaffirm our commitment, our collaboration with our partners like UNEP, ITC, FAO, and all. And we all work together for the best interest of the solving the problem our present society is facing. With that, I think I conclude here. If anything from anybody, otherwise we can stop the session here. Thank you very much. Yes. Okay. Maybe, Fran, I think we can.
Yep. Okay. Yeah. Thanks, everybody. Yep. Thanks, everyone. I think that'll draw this AIT Tech Talk to a close. Please join us for the next one. I'm sure there'll be some emails for it going around. Thank you. And thank you, speakers.
Thank you.